Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. In this video, I will explain to you on sample spaces and probability. So first of all, let me explain to you on probability experiment, where it is a process that involves chance which gives several possible results or observations known as outcomes. So we will do an experiment or a trial and the result will be called as outcome. So the example is, if you toss a single coin, the outcome will be head or tail, or if you roll a die, the result will be the number 1, 2, 3, 4, 5, 6. So that is on the outcome. So how about a sample space? A sample space is a set of all possible outcomes of a probability experiment. For example, if you toss a single coin, the sample space will be either H or T. So the number will be 2. That is on the sample space. Next, let me explain to you on event. So what is an event? Event is a set consisting of one or more outcomes of a probability experiment. So for example, the event of getting an even number when a die is rolled is the set of 2, 4, and 6. Now let's see this table here. So this table shows you the diagram of the experiment, outcome, and also sample space. For example, if you roll a die, the sample space will be 1, 2, 3, 4, 5, 6. If you pick an apple, the apple can be either good or bad. If you choose a color of rainbow, so these are among the sample space. And if you are looking at the birth of a child, it can be a boy or a girl. Next, let me explain to you on the tree diagram. So sample space can also be obtained if you use a tree diagram. So this is an example of tree diagram when you want to do experiment of tossing 3 coins. So for the first toss, you will get a head or tail. For the second toss, again, you will get head or tail. And for the third toss, you will get head and tail for each of the outcome here. Therefore, the total outcome is this one here, where you have H, 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 T, and until the last one, T, T, T. So the number of sample space is 1, 2, 3, 4, 5, 6, 7, 8. Then let us see this example here. Find the sample space of the following experiments where 2 coins are tossed. So we want to toss 2 coins. Let us focus just up until this tree diagram here. So you can see your result to be H, H, HT, TH, and also TT. Next, how about if you toss a coin and roll a die? So let me draw this tree diagram to you. When you toss a coin, you will get either head or tail, and you roll a die, the result will get 1, 2, 3, 4, 5, 6. Okay, and again, you will get 1 until 6. So you can see the result here stated 1H, 2H, 3H, until the last one, 6T. Next, let's see the third example here. 2 balls are chosen randomly from an urn. So an urn is just like a container. So it consists of 4 red balls, 3 green balls, and 1 white balls. Okay, and you want to choose 2 balls. So what are the outcomes? Let's see here. For the first ball, you will get either R for red, W for white, and G for green. And for the second ball, again, you'll get the same outcome here. So your total outcome, if you outline it, this is the total outcome where you'll get RR, RG, and so on until lastly GW. Next, let's see here when you toss a fair die. Okay, so a fair die is tossed. List the outcomes of the event of getting even numbers. So even numbers, the event of getting even numbers is 2, 4, 6. Next, list the event for getting a prime number. So the prime number is 2, 3, 5. That is your sample space. How about if 2 dice? How about if a die is rolled twice? Okay, so you can do a diagram like this. This is your first roll. You can get either 1, 2, 3, 4, 5, 6, or this is, and this is the second roll where again you'll get 1, 2, 3, 4, 5, 6. So this diagram here shows you the outcome. You can get 1, 1, 1, 2, 1, 3, and so on until you can read this. This is 6, 6. Now let's go on to the classical probability. Actually, you have learned this in school, where the probability of any event is denoted as PE. We can use the denotation of PE, which is the number of outcome of E, which is NE, divided by number of outcomes of sample space NS. So let's see the first example here. Find the probability when a fair die is thrown. Find the probability of getting even number. So let's see here. The sample space is 1, 2, 3, 4, 5, 6. Therefore, number of sample space is 6. So for even number, the event of getting even number is the number of 2, 4, 6. Therefore, NE is equal to 3. So what is probability of the event of getting even number? You just take the number of even 3 divided by number of sample space 6, and we can simplify it. Therefore, the final answer is equal to 1 over 2. Let's see the next example here. Find the probability of getting a prime number. So again, let us write the probability. Let's say the event is K, getting a prime number. So a prime number is 2, 3, 5. So number of the event of getting a prime number is 3. Therefore, let's see the probability here. Probability of getting a prime number is 3. Divide by number of sample space is 6. Again, you can simplify it. So the answer is 1 over 2. So take note that the probability should be a random event because it should have an equal chance of being chosen. Let's see the next example here. A number is chosen from a set of 1, 2, 3, 4, 5, 6, 7, 8, 9. Find the probability of getting even number. So let's see here from this list of number, the NS, number of sample space, is 9. And then let's see the even number is 2, 4, 6, 8. Therefore, number of the event getting even number is 4. Therefore, the probability is 4 over 9. We cannot simplify 4 over 9, so we can leave the answer as 4 over 9, just like that. Second, let's see the probability of getting a prime number. So the prime number from this list here is 2, 3, 5, 7. So the number is 4. So again, let's find the probability. PK is 4 over 9. Let's see the next event here. Find the probability of getting a number divisible by 3. So among all of this, the number which is divisible by 3 is 3, 6, and 9. So the number is 3. Therefore, the probability is 3 over 9. We can simplify 3 over 9. So our final answer is 1 over 3.